Welcome back to Introduction to Engineering Design. Today we're going to get going on our very first assembly, and that assembly is going to be of this part right here. It's the Automata Box. I've called it the Automata Box Basic, and it's essentially just the top, two pieces of the end, two pieces of the front, all glued together. When we put it together, you'll see that it's seamless. The finger joints fit exactly. They're perfectly flush, and the box will be very rigid and very nice. So let's get started. And the way that we need to start this, the very first thing I want to bring up is be sure that you've got a folder structure set up. So in this instance, I'm in 4th hour, and I've built my Automata folder just like we've asked you to do, and I've put all my parts in here. So you'll see I've got my box end, my box front, and my box top. Those 3 parts that you've modeled. I'm going to start out by making a new assembly. So I go File, New, Assembly. I can either double click on assembly or just click OK. This opens up a contextual window, and it basically says, hey, to start an assembly, I need a first base part. So I'm going to choose the top as my first base part. I simply highlight it and click open, or I can double click. Now you'll see this part's following my cursor around here. You're also going to see this little floating toolbar down here. So I want to really avoid just clicking and dropping the part because I want my origins to line up. So you can see that I can rotate my part around 90 degrees quite readily here using my X, my Y, and my Z. Rotate context toolbar that floats around. That's an option that's selected. If that's not showing up, you'll see right down here where my cursor is flashing. Go ahead and select that, and that toolbar should show up as soon as I bring my part in. So I want to drop this, like we talked about in class, by using the green arrow. You'll see the green arrow shows over on the left-hand side and also up in the right-hand side. I'm going to click my green arrow, and let's look what happened. The first thing that happened is you're going to see that my part shows as fixed. That's what the F means, where my cursor is showing. That means that the part is essentially just nailed into space, and I can see exactly where it is in space by highlighting and looking at the origin. So there's the origin of my assembly right here, and here's the origin of my part. You'll notice they lie one atop of another. Now you're also going to notice my front plane of my assembly lines up to the front plane of my part, top plane of my assembly to the top plane of my part, right plane of my assembly to the right plane of my part. This is really important when you start to look at analysis of your assemblies, such as the mass and some other physical characteristics. We need to have the origin determined for us by us, not just randomly where you clicked and dropped the part. I'll show you an example of that, how not to do it. I'm going to go ahead and delete this part out. And I'm going to insert another component. Actually, what I'll do is start right from the top, from where we started originally. So I'm going to go File, New, Assembly. This time, I'm not going to pay attention to my own advice. I will pick that same component. I'm going to choose my top, open it, and I'm just going to come in and drop it. Now you'll see that it's still fixed, but what you're going to notice is the origin for the front doesn't line up to the front of the assembly. The top doesn't necessarily line up to the top of the assembly, and the right certainly doesn't line up to the right of the assembly. So my origins are offset. We can fix that later on, but it's a lot more work to fix it than to just start out correctly. So let's go back and do this the right way. New assembly. I'm going to go ahead and insert my top. Open it. Follows my cursor around. I'm happy with the orientation, so I don't need to change X, Y, or Z. I'm going to go ahead and use my green check mark to place my top part. I've got my part fixed in here, so let's go ahead and put an end onto it. So to do that, to insert another component, I'm going to click on the down arrow here, and I can either insert a component or I can start a new part. So I'm going to go ahead and insert a component. It goes back to the folder where I got my first part. And I'm going to go ahead and insert my end. So I'll open that up. And this time I'm just going to drop it anywhere. Now after the first part, you're going to notice if you just drop it, it floats around. Don't spend a lot of time trying to orient the part into the right position visually. Let's do it geometrically. So in class we talked about mates, and we talked about a specific sequence to use the mate tool. So I always click on mate, and then I choose the type of mate. I want to use coincident, and remember what we talked about. If we can use coincident to a surface or a plane, it's a very good, very sturdy mate. So I'm going to choose this edge of my box. I know that that edge of the part aligns to the inside surface of my cut top. And when I hit that check mark and accept it, you're going to notice now that I can move this part back and forth, but it always stays lined up. So that took away 2 degrees of translation, actually 1 degree of translation, 2 degrees of rotation. So let's do a second mate. And I'm going to mate the top of my box to the top of the finger joint on the end. And accept that check mark. Now you're going to notice that the part only moves back and forth. You'll also notice that it still says underdefined down here. The last mate we're going to line up here is I'm going to go ahead and line up this little cutout surface with the little corresponding cutout on the top, and accept that. As soon as I do that, you'll see it says fully defined. You'll also see that the part does not have a minus in front of it. The part also won't move because this top part is fixed, and then my first end piece is fully constrained. So let's go ahead and put another end piece in. So I'm just going to go ahead and click Insert Component, browse to my other end, open it, drop it. Similarly, I'm going to go ahead and mate, choose Coincident Mate, choose my 2 surfaces to line up to, and you'll notice that in this instance, I don't really want it like that, do I? I can align them either anti-aligned or aligned. So I'm going to flip this mate. That's kind of the way I want it, but you'll notice it cocks off to the side a little bit. So I'm now aligned, or anti-aligned rather. My next mate, I'm going to go ahead and line up the tops. So I'll choose my coincident mate, top surface, and the top finger joint, and accept it. Now notice that I don't spend any time at all trying to move the piece into position before I mate it. I just apply the mate and let it do the work. I can slide it around if I'm not sure about what I have left to do, and in this instance you'll see it only slides back and forth, so I just have to line up this front surface with a coincident mate to the front surface of the top and accept it. And now you'll see it's fully defined. You'll also see that the minus sign went away. So let's put the front in real quick. I'm going to insert another component, browse to the front, open it, drop it in place. Now I'm going to choose my mate. Well, before I do that, notice that when it's not fully constrained, I've got a minus sign in the design tree. I've also got it saying underdefined down here. So those 2 things I want to get rid of. So I'm going to choose my mate type, coincident. I'll choose this inside surface. That inside surface will touch the inside surface of my finger joint, and accept that mate. Similarly, I'm going to choose the top of my finger joint and the top of my box. Now you're going to notice with that coincident mate, it tries to guess which mate alignment I want. I can force it the other way. So I can force anti-aligned, and it just flips the part over. So you'll see I can flip these back and forth until I get the mate that I want. I want these such that they are aligned, facing the same way. Anti-aligned is facing each other. Accept the mate, choose a coincident mate again, and I'm going to mate my end of the box to the end of the finger joint and accept that. I'm again fully defined out here. Last component I'm going to put in is going to be my front, the second file. Now I could open it from here, and that's good, it works well, but I'm going to show you a different way to do it. I can also come right over into my design tree, and I can grab my Automata Box front, the first copy of it, that's what that means, Automata Box front is the file name, number 1, and I'm just going to hold my control key down and drag it in. And you'll see how I add a copy. It's underdefined, it's not fixed to anything geometrically in the model space, so let's do the mates. Mate, coincident. I'm going to choose the top of my box and the top of my finger joint. First, I want them to be aligned. I am now going to choose the outside surface, coincident with the outside surface of my finger joint. Now notice that I'm choosing surfaces. I do not choose edges, and you'll see the difference here. That's an edge to an edge. I can get myself into trouble pretty quick using edges. So when you're first starting out, I'm going to urge you to use surfaces and planes. So those two coincident, and accept it. Grab my box, and I can see it moves back and forth. So now I'm going to make my finger joint end surface coincident with the end of the box. I'm fully defined. My modeling is done here. So now all I have left to do is to save it. So I'm going to go ahead and save this, and I'm going to name it my Automata Box Basic in my Automata folder. That's it. I know this has been a long video, but remember a few key things. Put your first part in, use the check mark. After that, go ahead and choose wisely with your mates. Choose the type that you'd like first. For this exercise, it should all be coincident. Choose the surfaces to apply it to. Don't choose vertexes, edges, or any points to use with a coincident. You need 3 mates per piece. I can hover through my design tree, and we'll do this in class, and look at the mates that made up this model. We'll show you how to edit those later on too. That's it. See if you can get that box put together. Thanks for watching.